Hello, it's David with Oklahoma Ham Radio, the YouTube channel, and oklahomahamradio.com. This is part two in the build of the Phaser Digital Transceiver. There is video one. I'll link it up there somewhere. I'm not for sure where it will show up, but I'll link it. This is a part of a playlist where I go through the build of this transceiver. The Phaser is a 4-watt single sideband transceiver for digital modes. It's set up specifically for FT8 and FT call, JS call, something I can't remember. But anyway, it comes with those frequencies, but you can program the second frequency to do something like whisper or some other digital mode. If you would, please like, subscribe, click the bell, all that good stuff, and stick around as I go through step two of the build process. Step two of the build process, you start out by installing the audio jacks. They're 3.5 millimeter audio jacks. I want to apologize. I'm still trying to get the recording down correct because it's awful hard to work on something with a camera attached to your head and not really be able to see where it's recording. But here I'm just simply soldering on those audio jacks and getting them ready to use. Again, this video is sped up by 20 times, so it does take a little bit of time. The next thing that you do is install 6 resistors, and here I'm just testing to make sure that I've got connectivity, with those audio ports. Make sure that the audio line out is getting where it needs to, and the ground is making it where it needs to. And next, I go into installing those their 10K resistors. Of course, finding the parts is always the fun part, but you can see right there on the board, I do have both audio jacks installed. Here I'm getting out those 10K resistors and identifying where to place them. It's R5, R6, R30, R32, R34, and R35. So finding where those are on the board. Again, the documentation on the next page. And if you print it double-sided, it's nice because you've got that image or that map of the board right next to, right across from the page that has the instructions. So that was really well thought out. Unfortunately, I did not print out the manual. So anyway, here I'm just getting those resistors ready. Now some of those resistors lay flat on the board and some of them stand on one end and you bend the other lead over and put it into the board. So you have to look at the board before you bend those resistors to know how you need to bend those resistors. But anyway, here I'm just mounting all of those, those 6 resistors and trying to figure out where they go. So when I was much younger, my eyesight, I guess, was better, but I use this little magnifying glass to be able to make sure that those solder points look good and that there are no hairs of solder going over and connecting where they shouldn't be. And right here, I'm just adjusting that resistor that I just put in because it was awful close to another, I think it was another resistor that, I don't want those to touch and bypass the resistors. So I'm getting the parts ready, trying to find C26 and 28. Those are capacitors that are the tubes. And I look for a little while and I take it back. Here I'm still getting some of those resistors out and getting those ready, to fit on the board. But I did find a hole that I had accidentally dropped some solder on, which plugged that hole. And I use those solder suckers. Basically, it's a suction tube. You see them on the desk every once in a while. There's one right behind the board that's blue. But I use those here in a second to clear out one of the holes that I'd accidentally dropped, I guess, some solder on, or came across when I drug the soldering iron across or something. But I'm going to show that real quick, and then I'm going to skip ahead. So by this point, I've accidentally covered that hole, and here's where I use the solder sucker to suck that, suck the solder out of that hole. Make sure that you clean the inside of that solder sucker out from the last time you used it. Uh, you know, before you use it again, you may accidentally drop solder where you don't want it. But also what I do is heat one side of the board, stick the solder sucker on the other side of the board, and suck it right out. The I have gone quite a bit ahead here just because all I'm really doing is putting through hole components in place and soldering them, and then clipping the back side of it off. It's kind of what you do when you do a project like this. So it's nothing too exciting to watch. Um, just make sure that everything stays clean on the back side of that board so that you don't end up in a bad place. Also, make sure that when you get down to steps, well, you always want to install the right components as per the instructions, but make sure, especially with Q6, Q7, Q8, which are transistors, that you get them properly oriented. So on the board, it has kind of a octagonal shape, or corners that are cut off a box. That's where the round side goes. Now that is on the silk screen on the board itself, so it's pretty easy to follow along. So coming up here, I switched the camera around to hopefully show more of the board, but this is showing that round side that I was talking about, and on the silk screen, the direction that that should go. So all I do is bend it over. I bend down sometimes one, sometimes two of the legs. Hit it with some solder real quick, and then go ahead and move on. You don't want to get these too hot. I've mentioned it before. Just hit it with a little bit of solder. If you need to go back, let it cool off before you go back and hit it again. Um, these do have logic in them. They are, transistors. They're basically making decisions as to where things or paths things should go, I believe. But I'm going to go ahead and speed it up again. So this just shows him, put that in, clip it off, just like every other through-hole component. You just want to keep from getting it too hot, is all. On, let's see, transistor Q9, that is a larger transistor. It does have a built-in heatsink on it. And, you can get that one a little bit hotter, but I still would not spend a whole lot of time heating that up over and over again. This one, those pads are very close together, and I just wanted to make absolutely sure that everything worked well on it. So now I'm looking for the next part. I think that's Q8, if I remember right. Nope, that's resistor R46. So that is a 1K resistor, and have to bend it around also to make it work right. Next is the LED that's on the board. If you're going to use the case, you don't necessarily want to use that LED. Let me make a comment about R46. R46 sets to where a heatsink that's installed later um, could touch it if it's up too high. So spend some time to get that thing pulled right down onto the board as close as possible. Otherwise, you will short out the board and you will waste your time. Um, you will learn a lesson, but you will waste your time. So the next thing after the LED, here I just push it down a little bit just to make sure it's down on there really snug. But anyway, next is the LED. Long leg of the LED goes to the square peg on the board. If you're going to use the case that they provide, um, or the enclosure as they call it, then you will not install this. However, it does make things a lot easier when you're testing to be able to see what's going on there. And I'll show that here in just a little bit. So we get that LED installed. I pull that down tight to the board as I'm soldering it. Make sure that it is nice and flush against the board. And then the next thing to do is install the IC that's an 8-pin LM393 that goes into the socket that was installed earlier in U8. Now it's important to get the edge right on this. So this chip is marked by either a dot or a little notch. Now your sockets are marked with a dot or a notch, and the silk screen on the board was marked with a dot or a notch. It's actually a notch. So here's the IC. There is I tried to show this, but those things are hard for my big hands to hold on to. But there's a notch on that end. Make sure it goes up to that direction. And what I do is just roll those pins in just a little bit on a flat surface that's non-conductive. You don't want to accidentally, shock it or anything like that. But put that in there, wiggle it, make sure that it looks like it's going in nice and straight. And then, when you're comfortable that all those pins are lined up, give it a little push and it'll go in. All right, the next and last part of step 2 of the build is the 2-pin header that gets added. I was looking around for that 2-pin header. It had come out earlier, so I went and pulled another one and put it in there. So, little 2-pin header on that card. Same card that has the power plug and audio jacks and things like that. So what I normally do is, you'll see me fumble around with it a little bit because it gets stuck to my finger. But you put it in there, I'll flip it over, hold it with the finger, get some solder on the tip of the soldering iron here, and then just tap it just to hold it in place. You don't want to hold it too long or that soldering iron on there too long because it will burn your finger. Those pins conduct the electricity and heat very well. So just tap it and so it gets held in place. Once it's being held in place, then you can go back and solder it. So here I'm going to go back into turbo mode, and this is the last piece. What I do next is, go review everything that was a part of stage 2 of this build. And I turn off the soldering iron here in a minute, but anyway, go through and try to identify everything that was a part of stage 2, look at the next screen, find all the dots, make sure that all the dots are filled, and then I go back and look to make sure that resistors were put where resistors were supposed to be versus capacitors and so on and so forth. And just make sure that everything's aligned perfect so that it's not touching. There's a lot of these bent over resistors, and you want to make sure that those things are not touching, that's for sure. So I go through. Here I'm going to pull this board out of the holder, and then I go through and just make sure that there's no little metal things on the desk that can short out that board, um, which is entirely possible. You're clipping a lot of these feeds or these little legs off of these elements, and you want to make sure that there's no little legs that are sitting there that can cause issues. And after you get it done, you go back and you find that there are some more still. So anyway, turn on the power supply and make sure that it's getting 12 volts. Um, this is a center positive, so it, when you wire that wire, you need to make sure that center is positive and the barrel is negative. You can see on the voltmeter there I was hitting right at 12 volts. I did that intentionally. And then I break out the laptop to launch WJST because you need that for the test. So the last part of step 2 is to conduct the test to make sure that everything is working as expected. To do this, you hook up it's the jack, the audio jack that's next to the power, and that feeds into the headphones on the transceiver. I'm sorry, on the computer. And then you've got to make sure that you do in fact have WJSTX configured correctly to use that audio device that for passing audio in. Launch WJSTS. Well, you may have to go in the control panel, make a few adjustments, but anyway, to get that audio going out the right path. But then you can go into WJSTX and you hit the tune button. So right here I'm just going through all of the getting the computer set up correctly to where it would in fact pass that audio through, which I'm not going to go into. There's plenty of documentation on WJSTX on how to do that, but when you click tune, theoretically the red light should show up. Should light up if you installed that. There you can see it is lit, in fact, and there's 2 points, actually 1 point that you'll measure, which will show 12 volts when tune is engaged. If that's the case, that's a good thing. When tune is disengaged, then it should show a nominal voltage somewhere around 0 volts, maybe 100 microvolts or something, but anyway, very, very low. So here I just go back through and make absolutely sure that I did all the tests that were needed to be done and that I didn't miss anything. But step 2 is complete and the tests worked as expected. On to step 3. Thank you guys for checking it out. Stopping by, make sure to unplug power before you move on to step 3. 73s. Bye.